So our first presenter, I think Eric Sachs, you can already go to your place while I say a few words. I'm very happy you are here. Thank you for coming. And of course, you see the interaction on the screens. Of course, this is all according to the actual valid hygienic rules. Of course, we all take care. We keep a distance physically, but it's really good to have you here and to discuss later on. And now to hear your presentation, let me say a few words about Professor Dr. Eric Sachs. He's head of the Institute of Information Processing Technology at the Karlsruhe Institute of Technology, short KIT. In addition, you are director at the Research Center for Informatik, Forschungszentrum Informatik, FZI, I think internationally known, and of course at the Hector School. This is the Technology Business School of the KIT. And you have been working very, very long, a lot of years. You have at the moment currently, I think, 50 PhD employees, which is a very impressive number. And you're all working on process methods and tools in systems engineering. And of course the whole idea of EE development, you bring not only your university experiences, of course you have a lot of years experiences in industry. You worked for Daimler Buses, you worked for MBTech Group. Actually, we are really, really happy to have you here as an expert, and I'm looking forward at first to your presentation and later on to your discussion. Before you start, a few words to our viewers about the opportunities to participate. You all already logged into our MEA platform. This is the event platform we are using today. So the first step you already taken. Of course, you see a chat for Q&As in this platform. So if you have any questions to the presenters, please put them in this chat and we will take them later on in the podium discussion. And a second opportunity to participate is our Wall of Ideas. If you happen to visit our booth 2 years ago in Hannover, we had this large wall which was empty on Monday. And it's some sort of collaborative art project. So a lot of people could write something down. Some people draw some very funny, interesting things on it. So we tried to put this in a virtual form. This is the Wall of Ideas, so you can put your ideas on, and I'm very excited to see what the result of this Wall of Ideas will be at the end of these 3 days. If you are not able to follow the whole program of the next 3 days, of course, you can see the different presentations and discussions afterwards in our YouTube stream, e-mobil BW. You should see a link on the platform to this. So now our presenter is supplied with some water, and this is from my side. Eric Sachs, the word to you. I'm very happy you're here, and I'm looking forward to your presentation. Thank you very much.
Thank you very much so far, Mr. Fischer. Thank you for the introduction. Thank you for the chance to be here virtually at the Hannover Messe fair. And one thing in advance, I hope you can see the slides. There I'm announced as the head of the Karlsruhe Institute of Technology. This, of course, is a funny thing. And I'm not really the head of the Karlsruhe Institute, the KIT. I'm head of the Institute for Information Processing Technology. And I recognize, if I knew that the background is beige, it's gray as well, I would have wear another jacket. But anyway, I hope you can see me and I hope you can hear me. Yeah, what will I talk about? The topic is architectures, software architectures in vehicles. And to understand what is currently going on, I think you have to go back to history. And I go back to history 20 years ago. When I started at Mercedes, I was once delivering to the rain sensor. The rain sensor is shown here. In the middle, you see an electronic control unit. On the left, you can see the mirror and the integration of the sensor behind the windscreen. On the right, you can see the wiper, and it's a closed loop. The wiper cleans the sensor, and it's autonomous. It's an individual system. So what we have is a sensor, an ECU that realizes the function, and an actuator, the wiper, and the frequency and the wiping speed. And this you had the chance to buy at a tier 1 delivery. Yeah, stepwise, year by year, this kind of integration grew, and in the end we have a kind of wild zoo of different ECUs. This is a signal-oriented approach. The CAN was the protocol to put that into realization, to communicate from sensors to actuators. And so stepwise, one after the other, we integrated these ECUs from different suppliers that you all know, tier 1s, tier 2s, into the vehicle. And the integration task was more and more a challenge. So at a certain point, we recognized that it makes sense to have a cluster of domains. To cluster domains and say, okay, look here, it is a high-speed challenge. We are in a powertrain area, for example, or we are in a body area where we have seats, heating, and not really real-time requirements. Furthermore, we had upcoming the idea of assistance systems, driver assistance systems. You can recognize that on the right top part. And stepwise, we recognized it gets more and more difficult, not when we integrate a park assistant, but the moment we want to combine a lane keep assist with an automated distance control to an highway pilot, we recognize, does this still work on this signal-oriented level of integration? So I already pointed out that we had a growth of sensing, a growth of capturing the environment. Ultrasonic was the first. I already mentioned the parking. But ultrasonic is slow and it is cheap, of course. And stepwise, we integrated radar. Who thought that radar 10 years ago had such an overwhelming success in vehicles? LiDAR. We still say LiDAR is too expensive. We have the cameras to capture everything around. 360 degrees around. We talk about bird view or something like that. And now we come to a point where it's very difficult to integrate like the old-fashioned way, to integrate one ECU after the other. Because it's difficult to do it like that because we get a kind of Warthog. I looked up the term. Warthog is in German Warzenschwein. More and more sensing, more and more antennas, and that does not work. So we double everything for each function. And therefore, we need something that covers on an abstract level the environment. And therefore, we have a fused environment. We now say, okay, it's important to put all the information I can get from the traffic, from the other vehicles, from the environments, onto the vehicle and fuse this information with all this sensing. And then we need a system, a functions-oriented view to cover that all. And then the new chances of level 4, level 5 automated driving come in. In the end, we have to realize that on physical layers, on physical levels, and still currently mainly in domain controllers. And I pushed the wrong button. I apologize for the little delay. And in addition, we open the vehicle. And we say now we have the chance to communicate with a cloud, whatever cloud is, to communicate in a way we talk about car to X, vehicle to X, and X might be another vehicle, might be a back end, might be a roadside unit, and we think about a lot of these ideas of updates over the air. So sending information from a satellite, from a station, from a back end to the vehicle in order to fix bugs, to enhance the functionality, or to improve the functionality and optimize things that you might have honestly forgotten during the engineering phases. In addition, why don't you think about a situation where you say, hey, do I really need such a lot of ECUs in a vehicle? I'm not absolutely familiar with the number of ECUs in the new S-Class of Mercedes, but some say we nearly reached the 200 margin. So why don't we put functions in addition into the cloud? And there we can even have self-learning abilities. There we can have a control over the air of vehicles in an area that might not be too safety relevant. And of course we know that the moment we do that, we open a gate. We open a gate that demands for new ways of security mechanisms. But the idea to save money that way, to save ECUs in the vehicle, wiring in the vehicle, and have this fleet of vehicles that learn and improve functions in the back end, this idea is really, really a hot topic. So we differentiate between the logical and the physical architecture and level. And next optimization step. When you talk to the premium OEMs, they currently talk about zones. They want to save wiring. They say really regional zones in a vehicle. And we do this as well and say, okay, we have zones here that realize parts or complete functions. And recognizing that idea, you will soon come to a point where you say signal orientation, where you really have to define, by the way, again, a number that is not proof, but I tell you that, 30,000 signals in the new S-Class. And if you want to manage this on a signal level and you want to be flexible for improving, for updates of functionality, enhancements, it makes sense to put on this high level of integration of fusion a service-oriented approach. Services we know, client-server architectures, we know from your office building, your printer works like that, your common database works like that, and you are much more flexible the moment you do it like that. And this is what we call then a hybrid architecture. Why hybrid? Yeah, because the service orientation is not the only thing. Talking to your management in industry and say, hey, I've heard a nice talk, and we realize now from scratch everything in service orientation. They say, are you mad? Because you have proved quality. A window lifter is a window lifter is a window lifter. And this is still the signal-oriented way how to develop. So hybrid, because you have to add, you have to mix now the service orientation, and you have to mix the signal orientation because you want to save what you've done before. And this is a challenge. And of course, Screamia work on that, and AutoSAR, to mention one, is working on that to save what you've done before, the way of thinking, the competencies you have in your engineering departments, and to mix that. And this is then the next hot topic. It's the cards, it's the components off the shelf that you want to reuse. And this was the effort of the last 10 years, reuse, and do not invent the wheel twice. The moment you have this hybrid architecture, you can ask yourself, is that enough? How do you handle what I already mentioned? How do you handle the over-the-air communication? Is that signal-oriented? Is that another way? Is this what you know from commercial gadgets like a handheld? How does it work in the end? So you need even a universal architecture in the end. And in addition, you have the infrastructure. You have the parking areas, for example, they have already an infrastructure. You have to communicate with roadside units, and they are sending signals as well, like here in that example, a traffic light system. So, what is the architecture of the future? It's neither white or black, it's a mixture. And an ideal way how you can put that is to say, okay, it's something where we have, in the end, a plug-and-play approach. Of course, I know that the realization of such a visionary thought takes a long breath and needs a lot of efforts. But in the end, for the reasons I've mentioned, we need these universal architectures with different sections, with different parts. And the idea, again, is to put sliders on. Okay, sliders, again, are naive to a certain point, but this is how you have to realize that. Because you can't solve the problems of a premium level 5 vehicle with the solutions you have for a volume vehicle. You have to differentiate between a Golf and an A8 or something, to mention another brand as well. So, and these sliders allow now to reuse a lot of the cards, to include a lot of infrastructure, maybe for vehicles of communality or of companies, and to have this over-the-air communication idea. And of course, and this is the important thing, and this is really a thing where we have to change thinking, is the service orientation, because otherwise we will not be able to handle the automated driving on that safety and security level. And this is my message, and this is my message for the discussion in the podium afterwards. And hopefully you use the online chance for further questions as announced by Wolfgang Fischer. And I'm keen on answering, or maybe I don't have an answer, then keen on discussing your questions with you. Thank you very much.
So, thank you very much, Professor Eric Sachs. Yeah, we have a bit of time left, so just one short question before the rest we take in the discussion. But as I said at the beginning, you have a lot of experience in the industry. You are now working in the research area. So for the smaller companies, as you explained a lot of our universal architecture, of course. A lot of the companies in Baden-Württemberg, they are very much specialized on one or two components. What does it mean for them? What is the challenge for them according to the universal architectures?
Yeah. So on the one hand, honestly, really honestly, it's the staff you have. Mm-hmm. It's the qualification of the people. They are highly skilled, but now they have to move that skills to a new topic. They have to move that to the new challenges, and this is a transformation. And this transformation takes place, and Franz Logan pointed out that the state of Baden-Württemberg is very much pushing towards that direction. And they're honestly, again, the fast will eat the fat. Mm-hmm. The fat must think about that and must change, otherwise they will shipwreck.
Okay.
So far, my opinion on that.
So this is in a nutshell. So thank you very much for now.
Thank you.
I think we talk later in the discussion. We have a lot of points I think we can discuss with the other two presenters. So I'm looking forward to later. But for now, thank you very much for your presentation.
Thank you.